Okay guys, in this video we're going to look at an example of a compound probability that doesn't really come out and say it until you really kind of think about it. But it would be an example of, say, somebody having a probability of being successful of doing something, but wanting to do it again and again and again and again. So for instance, free throws. And so let's say that a student has a free throw success average of 30%. Well, the first thing that I want to do is right off the bat just kind of over here say that the probability of them making a free throw, to be very honest with you, is going to be this 0.30 or this 30% that we're already told. So we kind of have to keep in mind that whenever we see a percentage like that, we're already being given a probability. And so letter A here says, what's the probability that out of 3 free throw attempts, the student makes 3 free throw attempts in a row? And so you got to look at this as the probability that they make one, and they make one, and they make one. And so when I write this, I'm going to write the probability they make 3 FTs, okay, free throws. But the way we've got to think about this is the probability that they make it. So they make a free throw, and then a free throw, and then a free throw. And the fact that these are all occurring in sequence with one another, so free throw 1, free throw 2, free throw 3, we could really look at this as the probability of free throw times the probability of another free throw times the probability of another free throw. Everywhere we see that and, replacing it with just a multiply. Now here's the thing, in terms of, are these free throws dependent upon one another, independent of one another? The first free throw is not going to affect the second free throw, and so on and so forth. And so since they're all independent, we don't have to write the probability that he or she makes the second free throw, given that they made or missed the first one. So if that's the case, then really what you can see here is that we're really going to take 0.30, which is our probability, as a decimal times 0.30 times 0.30, or really what I'd like you to see is this. Anytime you want to have multiple successes and you already know the given probability, then we can raise that probability really to a high, or the exponent representing the number of times you want to be successful with this thing, okay? And so in this case here, excuse me, excuse me, I would say then the probability that they hit all 3 in a row is 0.3 to the power of 3. So to the power of 3, we get 0.027, and it terminates. So to move this decimal twice to the right, there's about a 2.7% chance that a 30% free throw shooter is going to hit 3 in a row, okay? Now letter B, I like this one because it says, what is the probability that out of 3 free throw attempts, the student makes 2 or less hits? And the reason why I like this one is because 2 or less, well, that would be the probability that, they make the first 2 and, 2 or less hits. That would, I guess they can make the first 2 and miss the last one, make the first and last one, miss the middle one, miss the second and third one, miss the first one, like all these different possibilities. But what you got to consider is this. To make 2 or less is the exact opposite of making all 3. So when I write the probability of 2 or less, I want you to consider that we could really write it as this: the probability that they make all 3 bar. And that is to say that it's everything but making all 3. And so knowing that the probability of the complement of an event is always 1 or 1.00 or 100% minus the probability that it does happen, then what we get is this: 1 minus the probability of actually making all 3 would be the probability that they make 2 or less. So in this case, we can now just use the value that we just found in the previous step of the making of all 3 and just subtract that away from 1. Now I'm going to cheat. I'm going to subtract 1 away from this and flip the sign. But we'd say there is a 97.3% chance then that they're only going to make 2 or less. Now letter C here says, what's the probability that out of 3 free throw attempts, the student makes 1 free throw and misses the other 2? Well, the way you got to look at it is this: the probability that they make and then miss, the word and, make and miss and miss, okay? So we kind of look at it this way, but using the fact that I know the probability that they make a free throw. So we would say, basically, I'll write it this way. I guess I'll use the same verbiage here. Probability that they make it times the probability that they make it bar times the probability that they make it bar or miss it, okay? We would get something like this. The probability that they make it is 30%, but the probability they miss it is 70%. And the other probability that they miss it is 70%. So when we multiply all 3 of these together, I suppose that we would look at a situation where then we would have 0.3 times 0.7 times 0.7, and we would get 0.147, 0.147 would be our probability there, or a 14.7% chance. So in any of these instances where you're being told how successful somebody's going to be as a percentage of the time, then you're already being told a percentage or a probability, and so we can start to craft our probabilities using that. Cheers.